Hi everybody, I'll give you guys an update here from the forest today. Got a little setup here after all you guys' suggestions to try to see if that... Hey guys. Oh. Hopefully my connection's all good. Hi guys, thanks for watching. Welcome to the latest update. I'll give you guys a little update on what's going on with the eruption here. There hasn't been any huge significant change, but it's been a couple days. Wanted to reconnect and reassess what's going on with you guys. Let you guys ask some questions too and all of that. So thank you guys for watching. So I took into account all your glare suggestions here, and I got my setup here. I'll show you guys what I got going on. So we got the umbrella. We got the blanket over the umbrella. We got the cardboard box. All right, so here's our new little update cave for you guys. All right, so here we are, and I'll show you guys the tilt plots that we got going on here. Look at that, no glare. How about that, huh? Amazing. So yeah, it's been over a week now since our last collapse event, and we have our signals here of the volcano, what's going on here. So the first thing we'll talk about is how our plot's doing, and you guys can kind of see our 2-day plot is not really showing us a whole lot anymore. We kind of see an overall deflation trend. Basically, the thing is still depressurizing, going downwards overall. There's a couple little oscillation in here, a little quicker drop, a little slower drop, a little quicker drop. And maybe it's more useful now to actually zoom out, but we can look at the East Rift Zone here. Have a similar kind of thing, overall going down. There was something that happened earlier today, or it's just not exactly clear exactly what that was. Some kind of instrument adjustment, or whether that was like some small collapse within the crater. It doesn't look quite like that. It doesn't have enough noise on it. But overall downward pattern. I suspect that an area, this bump right here, might have been rain, but we can kind of connect two signals here together and kind of see how it works together. So now we're looking at our whole past week of tilt on summit and rift zone. The summit's the blue line, the rift zone's the green line, and our scale is now a lot less than it was before, just like I was telling you guys yesterday. Let's see if I can make it not blurry. See, there it is. So all right, so there, 2.5 to -2. So our scale is a lot less than it was before, right? Compared to like looking the whole month, we're from 200 down to -100. That's 300 total, and now we're basically at 4.5, right? So let's see if it's looking to focus for me here and see what's going on there. All right, so basically we still have that downward drop over both a summit and a rift zone over here, and we see that there's an oscillation pattern. It's a lot noisier, a lot fuzzier signal on a summit. We think there's a lot of kind of wiggling going on of a lot of loose blocks, loose pieces of ground over there with kind of cracks on all sides. We'll see if I can show you guys a video of that a little later on soon. But kind of up, down, oscillation pattern while overall going down. And the same thing is true with the green line from Pu'o'o. And the interesting thing to me is, if you guys look, we pointed this out earlier a few days ago, how when the pressure is higher, when the pressure is higher, when the inflation is highest at the summit, then that's when we see the biggest drop in Pu'o'o. And then when the summit starts decreasing, we see Pu'o'o kind of not increasing, but the rate of deflation decreases. So we have slower deflation, then faster deflation, then slower deflation, then faster deflation. And it kind of mirrors it. Yeah, you kind of see almost this like figure 8 little dance going on here, higher and low, low and high. You can see how it really kind of corresponds. The lowest spots of the green corresponds with the highest spots of the blue, more or less, not quite as exact over there. And then we had that earthquake, that 4.4, a few days ago, and that kind of disrupted the system right here. Instead of kind of going back down, we actually had a bigger inflation hump, right? And then in the middle of that is when we had our rainstorm as well, here on a green line. So it looks a little messier right in here. But you see kind of overall pattern besides this one bigger bump, which maybe was something from the adjustment of the earthquake that we're not quite clear what happened there. But the overall pattern is down still, going all the way down. So that's all depressurization. There's a month-long pattern, kind of put it in perspective. You know, our collapse events were fairly huge, and our little earthquakes are magnitude 3s in between there. We're also very impactful. And then since then, we haven't had hardly anything like that at all. There have been some earthquakes, but they've all been down on the south flank. So we can talk about those here shortly as well. But that's kind of the story of the tilt. And we can look at some GPS as well. So here's our GPS plots and some variations, maybe from the wiggling that we're kind of seeing as well, you know. So depending which second the measurement comes in, you might get a point way up here or a point way down here. But kind of overall, it's whatever wiggling is happening in the rock, that block of ground is kind of going back to normal. And you see similar pattern down here in this lower one as well. Maybe a little extra wiggling in between, but kind of staying, you know, not really changing slope that much, right? Sometimes a little wiggled that way or sometimes more that way, but overall pretty flat. And same story there. Looking at the long term for the past year, we can start to see our flattening out zone right here in the bottom right now. Right, and it's a little clearer now. You can see how this is flattening out now that our collapses have actually stopped. And so the whole question that we've been trying to pry at so far the whole last week is how much lava is still coming into the volcano, and is it able to work its way down to fissure 8? And we're trying to see if these connections of patterns of the tilt oscillations. Let's look at this plot again. You know, if this kind of pattern of the increase here and then the pressure kind of seeming to correspond at Pu'o'o, indicating some kind of connection there. So maybe there is some magma still pushing its way through and, you know, linking the pressure that way. It's not really clear. We talked about how that amount might be a huge drop in volume, something like 5% of that original volume potentially, just using our best guess estimate of supply from the Pu'o'o era. You know, so. But overall, the pattern is everything is basically dropping down and down and down. And, you know, I had mentioned, turn this around, you guys can see me in a cave. I had mentioned last week that when we saw the collapse event not actually come through, and then we were looking to see when the next one might occur, how long we might have to wait to tell what's happening with the eruption. And I said, you know, it's probably about a week to have some kind of clear signals, and then maybe 2 weeks till we're really sure things stop happening. And so it's been about a week. I just wanted to kind of touch on that. And, you know, what we haven't seen at all in the past week is any signs of more earthquakes at the summit. We haven't seen any signs of real inflation. We have seen these kind of cycles, oscillations in the overall deflation trend, and even with times when it is kind of inflating on the order of a microradian or two, maybe at most. But, you know, that could also still be the typical gas-driven effects as we imagine them. You know, that might be the cause of some of our old deflation-inflation cycles. You know, the shape of our graph isn't exactly right, you know, but it could be that there's some kind of other cycle that we're not that's not best described as deflation-inflation that we can actually characterized as, like, you know, some cycle of the thing kind of depressurizing or the flow reducing or that kind of thing. You know, I kind of imagine, like, when I turn off my hose at the actual faucet of it, right, and then if I have the hose plugged in all the way to the end and an open end of it, then the water starts trickling out, but at some point it kind of starts doing a little like a sputter kind of thing, sputter, like there's a little oscillation that occurs, you know, just naturally as the water is going out of the hose. So as the lava is moving through the system, it could be doing some kind of oscillation like that also, just because of the change in the volume as well. So I'm not quite sure what that oscillation means, you know. We're still kind of looking at that and, you know, seeing that there might be some connection there. But overall, despite the connection, the overall trend is that everything has gone down, such that, you know, at this point, you know, all signs are that the eruption is actually coming to an end, or has come to an end. As it depends how you describe it, right? You know, some people would describe that, you know, the huge drop in volume coming out of fissure 8 as like as the end of the eruption. You know, lava is still kind of bubbling up in there, still under there, and it still must be coming to the summit at some point also. So but it's not really coming out of the ground and covering any new area there. So I think once, to me, once I stop seeing lava come out of Fissure 8, any pictures that show not just glow, because glow, you can get glow from just hot rocks. After the lava actually recedes, then it probably will glow for several days without the lava. So just the glow on its own is not as convincing to me. But the lava is obviously there. But to me, being able to see it, let's say from a helicopter 3,000 feet up, that might be like the real landmark for me, is when we actually can stop seeing the lava bubbling up in that fissure. And I'll show you guys the last pictures we have, USGS photographs of Fissure 8, so you guys can kind of see what I'm talking about as far as lava being down in there. But that's kind of what to me will be the real landmark moment, is when the lava actually is no longer visible in there. And of course, lava is still draining down at the coast. It's still draining through the tube system and draining into the ocean. And if you guys just saw Ikeika's report this morning from the ocean entry, I shared it on my feed as well. You guys can see how there's still flow kind of oozing out there. It's definitely not as strong or as wide. The area is wide, but the area of active flow going in the ocean there's not as many points within that width as there used to be. So it seems to be kind of decreasing slowly as well. I wouldn't be surprised if that goes on another week even. So some people might want to wait until that lava stops trickling and there's any red lava there oozing out before they decide eruption is actually over. So it's kind of, everyone might have a different definition. The USGS is going to be probably a lot more conservative and, wait to see at least 2 weeks. There's no sign of inflation coming into the volcano, because, we've had pauses like that before, possibly longer than that as well. So, I think, it's that our initial assessment a few days ago that the huge volume of lava coming out, that chapter of it is basically done. I think that's still true. So we're still not sure about that kind of trickle coming up, and how that might manifest itself through the plumbing of the volcano. But it seems like that kind of, if you might call it, that's the huge flux, the huge volume that came out of it, was actually seems past. So before I get too far, let me kind of look back here and take some of you guys' questions. Thank you guys all for watching me. You guys check out my new little cave that I have to reduce the glare. So let me see. Mentioned the events, yeah. So signs of relief, yeah, for sure. Yeah, these are basically all signs of decrease. We've been kind of trying to, I've been kind of reserved and conservative and saying the eruption is over, because I wanted to make sure there's no sign of the thing getting blocked and lava still coming up, but it's just not getting out. And there is no sign of that right now. Just to kind of reemphasize that, it seems like lava is not coming in any faster than it was, and if it is coming in the same rate, then it's not building out pressure like it was before, probably because the whole thing is empty and drained and collapsed and cracked now, and there's a lot more space, right? We're seeing, it seems like, adjustments in the system between the gas coming out of the vents, not just SO2, but also H2S, the stinky rotten eggs, hydrogen sulfide smell that kind of comes from deeper down, or from the draining process at least. So, the fact that people were smelling different gases, it wasn't just the wind, but it was also the kind of gas that was coming out was actually extra stinky, and the kind that we're biologically predisposed to detect. So there's that. So let me see. Here's another question. So if the lava isn't at the summit and it isn't flooding out, where is it all going? Where's it not going at all, like stuck in the pipes? Okay, so I think just kind of recap what I was saying a couple days ago. I think there's two sources of the lava that was coming out, right? Maybe three, right? Let's say two sources of hot lava, like really new, fresh lava coming out. One is a lava. Just a second. One is the lava that was filling the whole summit caldera. So that's that huge amount that's been building up. You can imagine the last time we had a caldera collapse on this scale was around 1500 AD. So, not to say that there was a kind of a straight linear filling of the caldera, but it took 500 years of the thing filling and collapsing through various earthquakes all the way to actually get to the point where it could do this. So I think that huge buildup, that huge reservoir, huge bank of lava that was in the summit, that shallow summit caldera, is the one that I believe actually drained and fed most of this eruption that came out of Fissure 8, and caused the flow to fan all the way through Leilani and consequently past Noni Farms, Papaya Farms, all through Kapoho, around Kapoho Cone, then swinging south towards the Halanui, then swinging south towards Pohoiki. All that huge amount of lava, like the huge, the big bulk of it, I believe, was actually driven by that big bank coming from the summit reservoir. And I think that kind of corresponds when we see the stop and the collapses at the summit. The stop of the lava coming out at the fissure seems to make a lot of sense. And going even back farther in time, the slowdown of lava coming out of the fissure that we interpreted from seeing the oscillations, seeing the surges become visible, seeing the lava levels dropping, kind of stagnating and cresting over, all that whole pattern we've been talking about for almost a month now, right? Was all signs of the slowdown as well, as we at the same time noticed that the intervals between the collapse events were getting longer and longer, right? From maybe about a 24-hour cycle earlier on, and then it was a 31-hour cycle, then it was a 36-hour cycle, and in the end we kind of got to where we're having about 40s and 50s at the end there. So kind of all those things all go together, to kind of say that most of it was driving that eruption. The bulk of at least the last 2 months of it, was the lava coming out of the caldera. And so since all that has stopped, even the small earthquakes have stopped, and we kind of can assume that huge account of lava has basically been spent, right? So there is the other source that kind of filled it up in the first place, the source that feeds other eruptions that, that don't use the magma reservoir, that use other magma reservoirs, whether it's in the rift zone or deeper down, what have you. There's, not just one source, not just one chamber that can erupt from there, so, but the one that was used this time, at least unless something really unprecedented happens, that we don't expect it to kind of really change from that pattern again. So right now, there is no pressure coming out of the summit into the rift zone. Maybe that slight little oscillation pattern making it down to Pu'o'o, but basically, there's a lot less pressure every single day, and it seems less and less likely the lava's gonna rise within Fissure 8 again. It seems less and less likely it's gonna come out of anywhere else along the rift zone up there. And if that pattern continues, what we expect on a ground surface is, the ground to settle above that decreasing pressure. We do expect earthquakes. We do expect more gases coming out. Areas could be steaming quite a bit. In fact, not just the old fissure lines, but Fissure 8 itself. As lava kind of gets down out of there, and then groundwater can get in closer to there, then it'll kind of start steaming more continuously. And in fact, that could be the case at the summit as well. Someone asked about the steam at the summit, and I'm sorry, I don't know where I noted your name. I don't have it next to me here now, but someone messaged me noting that there was a pattern in steam coming out of the summit, right? Coming out of the various cracks in the early morning, and then kind of into a larger steam cloud that's rising up through there, that maybe the summit area is starting to get the water moving slightly and closer than it was before, and that's causing slightly more steam. And it's also true that in the early morning time is the best time to see the steam from there. A combination of the light and the coolness of the air makes it so you can really see every single crack steaming. Even before all this happened, it used to be the time we'd take tourists up there that really wanted to see how hot the caldera was underneath everywhere. You could take them up in the early morning and see, areas steaming all the way over to Kīlauea from the Halemaumau crater. So, there is that kind of effect, but I do believe that, that we should be seeing at some point cycles of steam coming up, like kind of building pressure down there. It could do something, it can build pressure enough to then force its way between the cracks of the rocks that are wiggly kind of thing. It could be that it takes a certain amount of steam to build up for it to actually build that, and that could be why you see a cycle of it up there. But overall, and the longer the eruption goes on, the longer the pattern goes on of having less lava coming in and pressure dropping everywhere, we should be seeing more and more steam. And actually, the USGS at some point last week said that the collapse pit is actually deeper than the water table, they believe now. So if this goes on long enough, then we actually might be able to see water filling that hole, the deepest part of that hole, which would be amazing. It'd be the stuff of old Hawaiian chants, in fact, yeah. if that actually happens, right? So so it was you, Linda. Thank you, Linda. The plumes in the middle, I'm not sure. The only thing I can kind of imagine is that there's like a buildup of gas, and then that there's the area in the middle is probably more. I mean, there's two kinds of cracks, right? There's like a crack kind of in the middle, and then a crack on the outside of the fault lines, right? So it could be that you have like a wiggly block, right? And you kind of wiggle it this way, then the gas on this side can come out, and you wiggle it that way, then the gas on this side can come out, or something like that, right? And then there's kind of cracks in the middle, but it might be that you're using the middle as one side and the other cracks. It's hard to say exactly how everything is moving in there. But I think it's interesting to watch. We're going to see if we can pull out some time lapses of that and do some analysis of that, and maybe see what we can see, and then see how that changes over the next day or two. As we see if we have that steam pattern continuing up there. Another thing that could possibly keep happening is, not just the settling of the ground, with the kind of cracks moving around and steam coming out, but often what happens when eruptions start winding down like this is you actually get collapses and form new little craters. So it's possible that around Fissure 8 you might get a crater. It's possible that you might get craters elsewhere. Anywhere between Fissure 8 and Pu'o'o can form a crater. Pu'o'o itself could keep collapsing and form a larger crater. Farther up rift, Maka'opui, where we believe a big source of magma also left, that shallow chamber underground, that could also form a deeper crater or collapse a little bit more. There's that kind of thing as well. So those are all kind of winding down effects, that I kind of consider like the fourth part of the phase of, how eruptions go, when we kind of simplify things for guests, as far as how the eruptions progress, the fourth part, eruption ending, and then everything kind of collapsing. That could be what we're actually into getting into there now. And for you guys who want to just brief recap, the phase 1 to me is the actual fissure, the cracks opening up. Lava comes out, usually on a curtain of fire that forms spider ramparts, that kind of thing. Part 2 being focusing of the eruption to a single point, usually forming a lava fountain. In the cases of Kapoho and Kīlauea, those fountains were almost 2,000 feet high. Fissure 8 never got into that exact phase, maybe because of the actual dynamics of the size of the hole or how much lava was coming out, or it's hard to say right now. Well, something I'm sure we'll analyze there as time goes by. But for whatever reason, the height of the size of the nozzle was big enough to let out all that lava that did come out. So that would be the second part. And the third part is when you kind of relieve most of the initial built up gas pressure, and you can start having more of a bubbling lava lake where the gas mixes into the lava more, so you have usually more fluid bubbling lava. And we didn't really have that long a stage of that. I suppose you could argue that we had like some kind of hybrid of that version with the fountains, right? Because it was kind of more of a bubbly lower fountain, series of fountains all together. It wasn't just like one hole, right? We talked about maybe 5 different spots, like where the lava was emerging from the fissure side by side, kind of forming a wider curtain right there that was, a larger vent, a larger nozzle that allowed lava to come out from there instead. And, if that goes on long enough, then lava kind of tends to spill over the crater that it's in, and that can start changing what's usually a cinder cone or a spatter cone into a lava shield. And we didn't have that, fortunately. We had, only the spillovers from the surges around Fissure 8. Otherwise, that would actually, it still remains a concern of mine. If lava does come back for some reason, repressurizes, comes back into the system, it's likely to resume at that phase. To resume with the building a lava pond, and then that thing spilling over and sending sheets of lava, kind of radially, right, in any direction from that point in particular. So. That would be the third phase, and then the fourth phase, lava retreats enough that you start having collapses, right? So then you form your craters and all of that. So just kind of brief recap of that. So I kind of went off on a little tangent there, but let's see. That was all. It was all important from that question. So let me see. Going back to the questions here. So let's see. Aftershocks for Mauna Kea. It's possible, basically the whole island is constantly adjusting all the time to the various events that happen, whether it's earthquakes from years ago or eruptions happening this year or the movement of the whole Pacific plate away from the hot spot. I mean, well, Mauna Kea and Kohala, for example, away from the hot spot, which not only stops the amount of lava coming in, but it also kind of stops the amount of heat coming in, so the rocks don't get as hot. They kind of cool and they start sinking. You know, the whole island is kind of like a, I don't know if you guys ever did in, you know, an old time science class, you know, when I was in school, and probably some of you were in school. You had like a Bunsen burner, and you had a piece of metal with one kind of metal on one side, and you know, another kind of metal on the other side, like a strip, and you put it over top of that Bunsen burner, and that thing kind of bent upwards because the metals expand at different amounts, right? The one expands a lot more, so it gets longer, and the whole thing curves up. And then you move it away from there, the whole thing kind of curves back down again, you know, that kind of thing. So the whole island chain basically is going over this Bunsen burner. That's a hot spot, and it kind of rises over top of the heat. And when it gets away from the heat, it starts contracting and sinking again. So kind of there's almost like a, if you could see plate motion, which takes, you know, tens of millions of years, and time lapse, you know, like in high speed, it would almost be like a standing wave, right? The thing comes over and it gets over top of that heat source, kind of rises over, and sinks back down the other side. So that whole crust of land rising above and then sinking back down, you can imagine there's a lot of movement of the earth with that. So that's why you see so much settling and you see earthquakes. And, you know, when we talk about the background rate of earthquakes on Mauna Loa, Mauna Kea, anywhere else, you know, this background rate kind of comes from that constant adjustment of the ground. And that's why we typically see them be more random, right? Not just like a whole bunch in one spot, but, you know, one here at one time, one there at one time, one back over there. It kind of, you know, more distributed a little more randomly. That's kind of what the background rate kind of is all the time. So to answer the question, I think that what you see on Mauna Kea usually is the adjustment of it, you know, to all the different things happening, whether it's the eruption of Pohoiki that's been going on, or whether it's the movement of the island, or the fact that it's a little farther from the hot spot by a few inches every year, those kind of things, you know. But in fact, you know, as far as Mauna Kea itself, I don't think that we have any indication that anything else is happening there besides that kind of regular background adjustment right there. So, and that's true of Mauna Loa as well. All right, so let me kind of keep moving on the question. Fish rate feeding lava tubes down low where you can't see it. It seemed like that was probably true for a few days, actually, because we saw the lava lake was bubbling up near the spillway into the lava channel. But it seemed like that only lasted a couple of days before the lava level within the pond dropped down low enough that you couldn't really imagine it going into the tube anymore. And in fact, now the lava level is down below ground level, or around ground level at Leilani Avenue, where Leilani Avenue used to be. So that it seems unlikely, if you are feeding anything into the channel, you're not feeding a whole lot. And in fact, more likely, the lava would probably be draining back into that pit from the tube if there was, you know, any kind of localized connection right there. So I don't believe that lava is being fed into the tubes anymore. But the fact that the tube in the channel was so long and it was so wide and so deep meant that there's still a lot of draining to happen, and that's why I'm not going to be surprised if there's more draining at the coast for another week or so. So there's that. Is there any chance for Kīlauea to have an explosion? That's a tricky question, right? So the thing about explosions of Kīlauea is you normally have to have the water in place before the lava comes up. And right now, the lava, even though it kind of drained away, the ground is still all hot through there, and it could be that the water is coming back in right now. So probably the sooner there's an eruption at the summit, the less likely it is there will be an explosion. And conversely, the longer it takes for the lava to refill the summit, the more likely the water will have filled in that spot, and the more likely that there will be an explosion that begins the next eruption. Whether that is in months or years from now, you know, at the summit, we'll just have to wait and look for the signals. The first thing we have to look for is signs of inflation, of magma coming back into the volcano and building some pressure. And that's what we've been looking for to kind of gauge or predict what this eruption might do next. And that's what we're not seeing at all. And that's why I'm saying that, you know, so far, you know, a week after that last collapse event, you know, a little bit over a week, that, you know, we can be a lot more confident that this appears to have a good chance to be over. And it's not obvious that something else funny happened right through there. So let me see what else I got for you guys. Plate temperatures. Let me pull it up here on the. Okay, then for those of you guys who are wondering about what the cave was, so here's my normal zone, and what I got going on now is I took all your suggestions. I got the umbrella, I got the sheet, I got the cardboard box, and we got the plates, right? So that's the new forest update cave here. I'm trying to make sure you guys don't get the glare so we can kind of see what's going on here. All right, look at that kaleidoscope of our traffic cam right now. So it looks like they've redone the whole color scale once again, because if I look at the numbers, I see minimum of 134, maximum of 168, average 160, maybe a little higher than normal, but it's a pretty sunny day. So, I mean, I can imagine that has a pretty big effect there. Nothing over 200, for example. So I'd say the plate temperatures are normal. Let me see what other questions I can get to. Yeah, Linda, I think I hopefully I addressed the steam there. We'll see if we can get the time lapse, and that'll be really interesting to see the time lapse of that. So, but in fact, you know, one thing to kind of emphasize is that, you know, I mean, Kīlauea is a volcano. That's what it does, is to erupt, and an eruption almost always comes up at the summit, more times than not. So it is only a matter of time before there's an eruption at the summit. And, you know, we've all been living with a fairly stable volcano over the last 35 years, as far as having the pool eruption fairly constant, you know, stable for those of us that don't live in Kalapana, obviously, or down in a coastal part of the national park, because there was clearly a big impact of that. But for people in Volcano Village, for example, you know, the last summit eruption was 1982, before the 2008 kind of reactivation of the Overlook pit, right, which eventually hosted a lava lake, which eventually spilled over and then drained away. You know, all that happened without a whole bunch of impact really to the summit. You know, I mean, you know, because while there were some small explosions that were localized to the area around Inner Halemaumau crater, the park was able to stay open that entire time. You know, nothing was really cracking outside of there, so that was all fairly stable in hindsight for Volcano Village. For Volcano Village in particular, it seems like that's going to be different for the years to come, because, you know, lava is going to come back in at some point. It's just a matter of time. You know, if it's months or years, you know, it might be better if it comes up in months, because then we might not have any bigger explosions if it can kind of push its way through, or if the explosions that we do have might be smaller because there's less water that's gathered in that area. So, you know, if I could pick it right now, I'd say, oh, let's push lava back through that big pile of rubble at the summit and make another little lava lake there and give it a nice little chimney to vent off of, so people in Volcano don't have to worry so much. But, you know, long term, it is an active volcano, perhaps one of the most active ones in the world. So, you know, we may have to live within the reality of living up here in Volcano Village as far as a threat of eruption up from the summit itself, you know. So, okay, I'll leave that one out there. Next question. Do I think it's safe to move back into Leilani? Maybe not quite yet. Maybe it's, you know, I mean, it looks really, really, really positive as far as what's happening in there. You know, if it was my house, I might feel probably more deeply the pressure of, you know, not wanting anyone else moving in already, or like, you know, looters kind of thing, or wanting to kind of start picking things back up and resuming a process of, you know, what was once normal life. So, I mean, I guess to me, you know, I personally, like I said earlier on in my broadcast, I think that I would like to see no lava in Fisher 8 at all, bubbling, sitting still or otherwise. You know, I'd like to be, you know, to be gone from there, you know, as a sign that if it's going to come back up, there'd be, you know, at least some time of, okay, look, it's starting to glow again, and oh, look, you know, oh, look, now I can see lava deep in the pit, oh, it's getting kind of high, you know, then that actually would give enough time to make some reactions, right? So, you know, if I did go back, I wouldn't go back in, like, you know, full bore. I wouldn't go in and say, you know, 100%. I might start going back and, you know, start cleaning up. You know, I don't think there's anything wrong with going in and starting cleaning up now if you can get civil defense to help you in there, just like I saw our friends Mick and Ann Calber did a couple days ago. So, you know, if you can get in there and do some cleanup and that kind of thing, you know, I don't see anything wrong with that. The amount of gas coming out of Fisher 8 has been reportedly reduced dramatically. So that was one of the biggest risks to me, right? And the fact that there's a lot less of that risk is very positive as far as going back in there and working in there. And, you know, that's also one of the signs that we would look for to see resumption of activity is gas emissions increasing again. So if gas increases, you know, now we have enough steps to take between what we have now and another effusion of lava at the ground surface that, you know, actually it'll be time to say, okay, well, now there's glow, now there's gas, now there's glow, look at all the earthquakes, you know, like it's starting back up again. And Not to say it's going to be over in a long term, but, you know, if you're going to try to squeeze in, you know, eke out a life in between these eruptions, which are going to happen, you know, possibly years apart, you know, in the area, possibly decades apart. Hard to say exactly, you know, then, you know, I mean, it might be time to start cleaning up kind of thing. But, you know, until I see lava kind of all the way out of there and you know, like I said, it's going to glow longer than lava is gone. So, you know, it depends on your comfort level out of there, you know, but one of my main concerns was the gas and the fact that the gases are way down. That kind of, you know, I don't see any problem with going in and checking out what's going on, cleaning out your yard, like start getting your plan together, you know, figure out like what kind of things you'd like to have in there as, you know, as you might consider camping, basically, you know, in your house, you know, until things are even more stable, you know. Probably the more time that passes, you'll actually get more comfortable. So we'll have to wait and see how that actually progresses, right? So maybe I'll leave it at that there, you know. You know, everyone's got to decide for themselves, really. But it looks a lot better than it has at any point recently for going back in Leilani and doing work in there. All right, so let me keep going. When this event is over, we're expecting more a lot of breakouts in the area. It depends like how it ends. The way that's ending now with all the pressure decreasing down and down and down fairly constantly, then I don't expect lava to come out of that area or anyone nearby right now until I see, you know, any sign of lava coming back in, of an inflation, you know, which might possibly happen still. That's why we're kind of withholding judgment. That's why the USGS, you know, as a government organization, has to be even more careful. And, you know, they wouldn't you know, they're probably thinking positive things right now, but they have to wait at least a full two days to see. So yeah, we'll have to still wait and see, but that definitely looks good. So all right, let's see. Let me keep scrolling down here. I gotta catch up again, guys. The comments are way ahead of me, so I'll catch up to you guys still. How much of the events in this eruption are in Hawaiian folklore history? There are a lot of parallels of that, and you know, we kind of mentioned a little bit of them when we talked about the Pilihiaka story with the collapse of the caldera. Maybe we can do a examination in more detail of that story at some point. But definitely, these kind of events have happened in folklore but in history before. I think probably you know, we've had caldera collapses, we've had big flows. You know, we've had, you know, long-term eruptions like Pu'o'o. You know, I think the particular order and sequence of them might be unique as far as like what happened at the same time. Like, you know, the huge summit collapse, feeding a big eruption out of the rift zone. Right after the Pu'o'o eruption, like, you know, that kind of particular sequence of things might be more unique. But as far as individual pieces of it, all those pieces have actually happened before. So there we are. Lava is not coming out of a new place. In fact, it's, you know, receding down almost entirely out of sight now. Almost entirely. It could be that tomorrow we see the last views of lava, or today. I know there's a bunch of people flying today. I saw a report from Ikaika earlier today that Paradise Helicopters is flying up a lot of the hub crew, that is, you know, the core of the hub crew that is volunteering, so they can actually see how this impacted their homeland, right? Which is, you know, things I've been describing to them myself, you know, for weeks and weeks and weeks. But it's different to see it with your own eyes and see the scale of it and see, you know, I mean, see the corner of the island that you know so intimately, like the back of your hand, you know, to be able to see it from above and see it all in one field of view, you know, that's kind of a special thing, and I'm really glad to hear having the chance to do that. So we should have more pictures later today as far as aerials, and maybe we'll see that lava is actually not visible at all at some point by the end of the day, or possibly tomorrow, unless something actually changes there. So, all right, so let me see. Keep going into questions. 2 sources and possible water. Yep, so let's see. Where does the water come from? So the water comes from the huge amount of rain that we get on the island, right? So it basically all sinks through our very porous lava rock and collects usually about halfway down to sea level, and that's our groundwater. Most places have fairly shallow groundwater, you know, just within a few feet of the surface. Not everywhere, of course. You know, here on top of the volcano, you know, it's pretty deep. That's why a lot of us here who live here in the volcano area and much of Hawaii actually have rainwater catchment it rains enough from the sky, we can just catch it off our roofs and put it in big above ground tanks. You know, our tanks are big enough, not just for our household use, but also for fire suppression as well. So we normally got to have at least 10,000 gallons, so you can, you know, a fire truck can come pull up and use your tank for a local water supply to put out any kind of your neighbor's house on fire, for example. So the water table is quite far down, down by the ocean, you know, where, you know, sea level is right there. Then, you know, the water comes up as springs, sometimes right at the shoreline underwater, sometimes just on land. You know, that's why we have the hot ponds around Pohoiki. That's why we have areas like Kīlauea that have fresh spring water coming out from the sand, you know, right along the shore. When you swim through there, you swim through cold and warm and cold and warm. So that's kind of where all the water comes from. It's all sitting in the ground. There's a huge amount of water inside of our volcanoes, kind of everywhere except where the lava is kind of, the magma is kind of keeping it at bay just from the heat. And that's where you have that's the source of the steam. Okay, next question. What caused lava to leave Halemaumau in the first place? It was a buildup of pressure. So lava, that slower trickle that had filled that whole bank underneath the summit, that had been fed a pool eruption for 35 years, was enough that the amount coming out of Pu'o wasn't enough to clear the backup, right? So lava, you know, Pu'o itself, you know, had fissures on either side of it. Over the last several years, it had the lava lake inside of it rise and spill over. The lava lake at Halemaumau obviously back, you know, kind of also filled higher and higher and eventually spilled over as well. So there's that whole thing, right? You know, and in fact, that's probably a good chance to kind of maybe, you know, consider our earlier estimate when we were talking about the Pu'o volume being something like 0.3 to 0.6, you know, coming in a million cubic meters a day coming out of the volcano, compared to what might have been up to 15 out of fissure 8. 0.6 maybe wasn't even, you know, maybe isn't the best number to use. Maybe we should even go a little higher. Maybe we can, you know, be a little more liberal, because whatever was coming in wasn't enough to get out, right? There was backup happening as well. So maybe we can go back and revise our estimates based on that. But overall, basically, it was all a buildup of pressure. The pressure that kind of caused, and I saw a notice today, one of the comments from USGS, you know, there was a big crack open on the west side of Pu'o on May 1st, I believe, or maybe it was before that, you know, before the 6.9 earthquake, showing how pressurized the system actually was. It was pressurized enough that the, you know, lava was spilling out of Halemaumau. It was spilling out of Pu'o. It was causing cracks on the uphill side of Pu'o. And all that pressure was enough to actually unzip the rift zone, crack it from Pu'o all the way down to Leilani. And that's what fed this eruption. And that crack was fed by the pressure. And then once the crack was opened, then that's what allowed the caldera to actually drain out through that crack. So it was kind of a 1-2 punch kind of thing, right? It was the, you know, the slow trickle that caused a buildup of pressure. Buildup of pressure caused a crack, and the crack caused the huge outflux of lava that had been built up over years. So that's kind of how I'm seeing it all together. So okay, let me see. Oh, thank you guys. They're all joining and watching. I'm just seeing you joining now. I'm scrolling down through my comments, still getting there. Yeah, so as far as going home, yeah, obviously electricity and roads are going to be issues. I'm not sure even when civil defense is going to allow people to move back in officially. So we'll have to wait and see what the government response is to that. Do I know if USGS is doing any surveys to see if indication of lava moving? Yes. So all the monitors that we're checking on, USGS has additional ones as well. The ones we have are representative of what they have, you know. So we're looking at the simple version of it. They can look at a lot more instruments and signals and try to analyze this at every different location and try to connect the dots from one piece of the rift zone to the next all the way down. So I haven't been doing it in that detail for you guys. But they also are saying that there is no indication of lava going into the lower east rift zone. We don't see any signs of that happening. No signs of pressure building anywhere down within the whole system, in fact. And then, you know, in fact, the gases coming out are also at I think a 10-year low at least, something like that, which is really, really dramatic. So, all right, let's see, next question. Now the fissure is at ground level. Can someone measure from the inside to the top, just for the sake of doing so? Yeah, let's send somebody in. Just kidding. You know, yeah, I'm sure they'll see what the measurement actually is. One complication though is that they've already reported the fact that the cone has been collapsing. So we saw a number earlier today that didn't quite believe, so I'll hold back on saying it until we make sure it's actually correct. But the cone is still collapsing. It's getting shorter now because the lava that was filling the whole inside of it was actually holding up the walls. So it may be that in the end, the measurements that we had at its peak of fountaining are going to be the best we have, because unless we had a satellite fly over that exact window of time to actually give us like a satellite measurement to the ground level, and then compare that to the measurement it did before that, then we probably won't exactly know. But that's probably the challenge there, is the fact that the cone is collapsing under its own weight as we speak right now. So all right, let's see. Cave, all right, here we go. No glare, awesome. So, well, one corner of the umbrella. Let's see if I can find it. Where is it? Back over there. Oh, I see what you guys are talking about. It's right over here. Hold on, let me make that little adjustment right there. See, right over here. All right, let's try that out. All right, turn this thing around, and I think I fixed it. All right, now I can just hope it's not windy or the kids don't pull us down for the next time. I might have to do this every time, but but there you go. So, okay, Michael Ross, thanks for your comment. Some explosions with fruited magmatic ones, surges are associated with long periods of low magma supply. That's obviously far from the current situation. So yeah, that's very true. I think we maybe need to step back a little bit though, given how wrong we were about the 24 event, how it may have happened, and kind of re-examine how that actually happens. Certainly what you need with a period of low magma supply is long enough time for the lava to not come into the summit to allow the water table to really fill the summit caldera sufficiently, right? So that's kind of what I'm saying, as far as the longer we go without a summit eruption, the more likely we'll have an explosion. So if the summit magma supply rate long-term is still the same as it was before and has not decreased, then we will see lava coming to the summit sooner than later. In time, probably to keep the water table at bay and prevent the lake from forming in there. So that's basically the race there, right? Is how fast does magma come up compared to how fast does the rock cool and the water table get into there. And obviously, when you have a lot less lava coming up in periods of low magma supply, that's probably where we get that idea of it being low magma supply, is the fact that it has to have enough time in between eruptions for the water table to kind of refill that caldera area. So that's the thing, I have no idea how long that would actually take. I would imagine it would be many years. So that's really the question, as far as the summit goes, is, what do we see as far as inflation at the summit? If we see inflation sooner, that would be a good sign, like I was saying, lava can push back into the summit without too much time passing to create those explosions. So thanks, Michael, for your comment here. That's obviously correct. And just to kind of try to clarify to anyone else who maybe wanted to know more about that. So, hi, Brad. Good to see you. Seeing you guys coming in here. I do not work for the USGS, just to reiterate. I did once volunteer and contract work for them. But a lot of my knowledge has been basically from being able to follow the volcano on a day-to-day basis. From that time up until through doing tours and this kind of things. So between Fissure 8 and 9, I'm not that concerned right now with magma moving back into 9. There's not enough pressure to even push it up out of 8, so I don't think that's going to be an issue for you guys. So let's see. Temperatures. So another comment by Michael. Michael is another very well-educated volcano researcher. So I always look at Michael's comments with big interest. So he writes, the trend from SO2 emissions from Pu'u'o increased dramatically as eruption stopped. And that could be part of the mechanism as to why the eruption stopped. Degassing started at Pu'u'o and left the magma without enough gas energy to erupt. I'm going to think about that one a little bit. The way that I imagine the gas coming out of Pu'u'o, the fact that it actually increased and then decreased again, leads me to believe it was some kind of pocket of gas from somewhere down in there. I'm not sure exactly. It must have been within that upper cracked part of the rift surface above the magma conduit in the rift zone. So there, there's a magma coming down farther down, and above it the area is all cracked above there. That must be where the gas was moving through somehow. It's hard for me to exactly imagine the dynamics of how the gas might move its way through deeper, like at the top of the rift zone magma conduit, for example. I'm not sure exactly how that would go. But the fact that I think the emissions increased, to me, indicate that some pathway opened that wasn't open before, and that must have opened because of the decrease in the pressure of magma somehow, whether it was the magma itself blocking it, whether the magma was pushing the cracks in a different, pinching them in a different way. I'm not exactly sure as far as that goes, but certainly, I've always said that gas is the engine that drives all eruptions, and so seeing that big burp of SO2 out of Pu'o, as a kind of the last hurrah was, that was meaningful to me also, because, you did lose a big amount of energy that could have actually pushed lava out. It didn't push lava out. It basically just emitted out as a bunch of SO2. And so I think when we look at the fine details of how the eruption stops in its in its final throes, that could be a big part of it. But fundamentally, the caldera stopped collapsing, and we believe the caldera collapses maybe were also forcing more gas to be dissolved in the magma. That's maybe part of it as well that we need to consider. But the fact that the actual collapses stopped, that in and of itself, to me, is got to be the main factor. That we basically exhausted the physical size of that shallow summit chamber. That to me is, fundamentally why the eruption is slowing down, and ended that major outflux phase. So, I think we have a lot more to learn about the gases in general. I've kind of been saying for several years that I've always wanted to know more about how gas is stored within the rift zone, because it must be a very important thing. Going back to the Kīlauea eruption in 2011, I think we estimated something like 15,000 or 20,000 tons of SO2 came out in a single day back then. So we knew that we had big pockets of gas somehow moving through, and we didn't know where they were coming from exactly, if they were being stored in the rift zone or coming from the summit through the rift zone. I wasn't quite sure how that might actually work, and I'm still not quite sure about that. But we know that wasn't obviously a one-time thing. We saw that same level of gas emissions, throughout most of the fissure rate phase of the eruption here. So it could be that was driven from the summit magma being extra gassy, and somehow, the gas stored in a summit chamber. I'm not sure. I'm just not sure how that works exactly. But the gas is, I think, probably the most important and interesting parts of, understanding how eruptions actually happen. So we'll have to leave it to someone else's expertise, to give us more insight about that. But I think you're totally right, Michael. That's a string we need to keep pulling on to see how where those kind of questions lead us, as far as how eruptions occur, and how they begin, how they end, and when they actually break the ground and when they don't. When you have an intrusion and supposed to an eruption, all those things must be really, really connected together with the gas, I believe. So, okay. Another question is about the tephra particle inhalation danger. Yeah, that's definitely going to be an issue for everyone who goes back into their places, especially when you're kind of cleaning. You definitely need to be wearing your ash particle masks. Just the little ones that cover your mouth and nose. Same as you'd work when you're using your sander or what have you, that kind of thing. And I think that after you kind of break most of it down, so I've heard of people using lawnmowers and just running their lawnmowers over this stuff, and that's up to you. If that's what you want to do to your lawnmower, that's all good, but you should be wearing a mask if you're doing that, for sure, and probably goggles, because that sharp glass dust can get in your eyes also, so one approach is to kind of just, to just kind of leave it and let it kind of break down on its own. Another approach is kind of take it and try to chop it all up yourself, and if you do that, you're basically, working in a fiberglass factory that day. So protect yourself, like I'd wear, want to wear long shirt, long pants, that kind of thing. Make yourself like a little suit where little particles can't get any difficult. Don't want to breathe in that stuff. That stuff is very, very dangerous, especially in the long term. So yeah, you guys be very careful if you're going back in those areas as far as that. But the more time that goes on, the more that should naturally break down as well. So okay, let me keep going. I gotta catch up. How's Scott? Scott's doing all right. I think his plane is undergoing its maintenance, and I believe he is in the air. I'm not sure if he's in the air with his. I think he's got another leased aircraft right now. So I believe that he is actually flying today. I believe Harry Durgan's going to go with him at some point, and we'll get some photographs at some point of that as well. So okay. Farther on. Fracking. I don't think fracking was what caused weakness in the land. I know that fracking does cause weakness in the land, but the land was already weak there. I know that the volcano has basically been doing its own version of fluid injection, into the volcano for eons, right? So, and that's what the magma is a pressurized fluid injection, so you guys basically have the same idea, of what's going on, the right idea of what's going on. It's just the volcano is the one doing it with the magma. So, without getting into geothermal itself and, what fracking can or can't be, it's quite likely that they did fracture rocks down in there. I don't think they were doing it. Well, I don't know for what purpose they were doing it, if it was, an error or, just part of the research, whatever else. But in any case, I think the connections, between geothermal and eruption can be something that we research long term, beyond this, But as far as what I believe right now, I think it was really all magmatic, the magma pushing its way into that area. So we know that there were lots of kind of test wells that were drilled, and if that was the case, then maybe each one of them would turn into a volcano. It's not the case. It's just certain ones. So to say, okay, well, that one happened where there's an eruption now. Well, I mean, they put holes all over the place, So just a hole in the ground doesn't mean that that's going to be where the lava comes out. There were so many places. I mean, there could be a correlation if the volcano is like on its tipping point, like I was saying before. It's all a matter of equilibrium, right? If everything's out of balance, then maybe like one small push could set off an eruption, But as of what I know right now, I don't believe that the fracking has anything to do with it. So okay. Brad's going up with Scott too. Awesome to hear you guys. Oh, in fact, I see Scott's sending in some pictures now, so maybe we can get to those here in a little while. Okay, let's see what we got now. We got earthquakes. Okay. How is a 4.4 quake an aftershock from a 6.9? So an aftershock, there's kind of different ways to define it. The one that we're not holding to as closely now is the kind of time period. Some people would say that you need to have a much shorter time in between for it to be an aftershock. But geologically, maybe we're more concerned with which piece of the ground actually moved. And if it's shown to be a very similar piece of ground as the one that moved before, even if it's been months later, you might be justified to call it an aftershock in that regard. So I think what the GS is really trying to emphasize is that earthquake was a south flank earthquake and not a summit earthquake. Where? Oh, I'm back to green. All right, green doesn't last long. So, all right. So here we are in a cave, and here's our earthquake plot. So a lot less earthquakes overall. We have, let's zoom in here, a couple of summit ones. Oh, let's try to get some focus there. Oh, there we go. All right, so we got these kind of summit ones. They're not that surprising. And basically, let's see, this is only one day. So let me push the 7-day button here, and let's load up all 7 days here if we can. All right, so we lose our 1-day ones? Or are they on there still too? Okay, they're still on there. Still on there too. Okay, so the area was, this is a 4.4 right here. So this is the area of the south flank, right, that actually moved. So most of the earthquakes happening now have been on this area, the south flank. The rift zone moves through here, right in there. So as it kind of injects, it kind of pressurizes this area, and push this whole side to the south, right? This side to the north is harder to move because it's got the big mountains and the rest of the island over there. It was like a big support, a big buttress, right? So usually when it pressurizes, you get more movement going this way from the south flank than this way going to the north. So in any case, that kind of moves to accommodate that injection of pressure. Now that pressure is decreasing, it's basically able to settle or adjust, whether, you know, that's some local way underground here, right? So you can imagine that that piece of that fault line, you know, deep underground, you know, is not just a straight line, but it's got bumps. It's got little bumps in it. So if that piece of rock above it is kind of sitting on a bump in a slightly unstable way, it could kind of settle either direction, you know, but kind of just settle down if nothing's kind of pushing it, holding it up anymore in that direction. It's likely to slide, actually, the slide kind of back towards the rift zone slightly. So that's why you have the sliding going in and the cracking occurring along the rift zone itself, and kind of everything kind of trying to drop back into it because of the lower pressure right through there. So that's what most of those south flank earthquakes actually are. So you can kind of could group that 4.4. That 4.1 was similar. The 4.1 was slightly shallower. But it actually was in a fairly similar location right through here. So, you know, there's not just one crack, but there's several layers of them. So it could easily be that all three of those, a 6.9, a 4.1, and 4.4, are all related to each other, basically. So I think that's why they're calling it an aftershock. Is basically, you know, I think so. Finishing the rest of your comment, you know, it's a result of land formation from decreasing pressure, so certainly related, but why call it an aftershock? I think you're just trying to, you know, relate it to the fact that it's not a summit earthquake, which is what everyone here in Hawaii is sensitive to right now. Is that, was that another summit collapse? And basically, I think the reason to emphasize that is that it's not a summit collapse. I think that's basically what they were getting at there, as my own reading of that. Cool. So we have some eruptions in volcano Katkovik. In Alaska. So that's interesting. We'll look at that. Okay, someone's asking me a tough non-geology question here. Okay. All right, Keith, I'll give it a shot. Is it more economical to build a new area than to repair infrastructure? And a long delay for the cooling. So I don't know. I think you gotta reassess, you know, when you're gonna rebuild, especially in Zone 1. So I think if you do redevelop areas in Zone 1, then I think you probably would like to have them be agriculturally zoned, right? So you don't have as big a population density in those areas, that kind of thing. And, you know, it may be cheaper, you're right? You know, I don't know. You have to look at what Helco would have to do, or what, you know, water would have to do, how all those services, utility services get reestablished or not. You know, it might be easier to reconnect them to what's going on there now. You know, certainly in some areas like Poho, everything is all gone, so you really could just, you know, that's a much trickier situation there. So I'm not really sure. I'm not sure what would be more economical, I suppose. You know, I'm not sure if I really have an answer to that. It would require more math than I know exactly. I would imagine that, for example, down at the coast by Mackenzie, it's definitely going to be cheaper to just rebulldoze over top of that lava flow than it is to make any kind of new path around anywhere else, right? So hopefully that can happen as soon as possible. Okay. So, all right. Hi, Nathan. I see Nathan's got some comments too. I'm sorry, guys, I'm still not caught up, but when we're on our earthquake maps, there are 2 deep earthquakes over here by Pahala. They're really far down. You know, it could be magma moving its way up into Kīlauea once again. The magma kind of comes up through here, then it kind of moves sideways to here, then it kind of comes up over here again. It could be that. It could be signs of the next kind of pressure wave beginning. Or it could be signs that the thing is kind of tailing off, right? Because, you know, usually what you see is, you know, by the earthquakes is an adjustment of the conduit to either more or less pressure, right? You know, down that far down in the ground. And let's see how far down that actually is. Let me touch that. Earthquake, 45 kilometers, right? That's down almost as far down as you can actually get. So without as far down as you can get to have an earthquake, because if you get much deeper than that, the rocks get so hot they don't break anymore; they start flowing, and without a rock breaking, you can't have an earthquake. So that's what I mean by about as far down as you can get. So that's got to be close to the magma generation zone. So wherever the magma is actually feeding at the base of the crust, you know, by the hot spot moving into the crust of the earth through there, you know, that's more or less where that's going on through there. And whatever it is, you know, it's so far a way that I don't think it's going to affect what we see going on here for maybe a year. I'm not really sure, but that's kind of what, the order of magnitude in my head is that, it would take a while for any signal from there to work its way all the way through. But if a year from now we see another huge surge of lava coming through, we might look back and say, okay, well, that might be a kind of signal. Still, I don't see enough of them, really. And, most of the time when magma flows through the conduit, at a steady state, it doesn't cause these discrete earthquakes. It causes what we call harmonic tremor, the long-term vibration of that pipeline coming up. So it doesn't mean that there is not magma coming up, because then that kind of comes up without earthquakes. It usually means some adjustment of the pipeline itself, the area feeding into the pipeline. So those are interesting, but really inconclusive as far as what that means at this point right now. All right, so can we go back on? Let's look at some of the photographs, perhaps. Hi, Gabe. Let's see. More talk about gases. More talk about fracking. Thanks, Michael. You're following up here. I'm catching up to the conversation here. But yes, we'll only keep moving. Every field eruption is a successful intrusion. Yes, absolutely. I like that one. Okay. Oh, I might have to go get my battery here shortly, but let's see how long we can go. I still got 20%. Keep going. I'm not gonna do the fracking discussion right now. You guys, I see you guys are all having comments on that, but maybe we can do a little bit more in depth of fracking at some point and talk about some case studies, that kind of thing. See you guys all discussing, so great, thank you. Deep earthquakes. All right, I see Dane is in here. Hi, Dane. Thanks, guys, from Hawaii Tracker. We'll get to the pictures here shortly. The fuzziness of tilt is getting a little bit smaller. Mr. Lyman is going to wait for the USGS to weigh in. That's absolutely a prudent thing to do. The USGS is going to be they have a lot more data than I have, for sure. They have a lot more minds examining what's going on there, for sure. I think most of us would just wish they would share their theories more, and you can understand why they don't. And that's kind of just that little gap I'm trying to fill here. Is anybody who doesn't have the patience or would like to have some thought process of their own before any official announcement of what's going on. That's what I'm trying to kind of address in here, is give you guys some of the info, and as usual, let you guys decide for yourselves. And let's see. Nathan's bringing up the possibility of the deep pool connection, deep source for lava going into the rift zone. That certainly still seems possible. It could be that actually exists and it's used sometimes and not other times. But I myself have not been convinced, even though there have been some suggestions of a connection down there. Nothing has been very convincing to me long term. So I think that what we're seeing now is magma coming through the magma chamber and then going to the rift zone still. Yeah, and I think that when we see the kind of correlation of oscillation, even though they're inverse to each other, of the summit and Pu'o'o, that I think supports that idea as well. All right, so okay, so let's see. I think I see Michael talking about the Pauahi station, the bend in the upper east rift zone, for sure. the Deep Pahala earthquakes may be associated with the Bend Deep Conduit. That could be true as well. Yeah, for sure. That's this possibility that when we see the earthquakes down under Pahala, that's that little odd geometry in that conduit causing that pressure to kind of cause earthquakes, where normally it doesn't do that. So there we go. Let's see. All right, guys, I'm back to green. Had to leave the cave here shortly, and I think I'm not sure how my sound is doing. Let me switch earbuds here. This other one is out of juice. All right. So yeah, the connection's been pretty good today. You guys don't know what I'm talking about for the cave. Here's my little umbrella cave. Not as exciting as a volcano, but this is what it takes. This is our little side story. I got my little... It lets me come in so we can look at this iPad with no glare. All right. All right, so let us see some pictures that a couple that I've collected here. So this picture from yesterday is on Hawaii Tracker. I'll look up the lady's name who photographed it and sent it there. Give her some credit. But this is a view of the area of Pohoiki, right? My pointer. There's a boat ramp right there. Here's water right through here, and right over there, that's sand all the way around the end of the break wall right there, and filling in the area all through here. There's a little low spot, I believe, right in there as well. That seems to be maybe a little tide pool, something like that. It's hard to see exactly. But now you have a couple little water areas here and here as well, right? And it seems likely that most of the sand is going to keep pushing in, and it may wrap around and fill much of the area of this bay right through here, at least right now. We'll have to wait and see after, if at least one winter passes where all the sand moves. There's a lot more sand upshore, and it's filling in lots of the areas. It's going to all move around quite a while, so we'll have to wait and see where all the sand eventually distributes and where it kind of stays parked in the long term. But what we do see is the sand is moving around, and now the sand is what's basically blocking the boat ramp. Even though lava flow in this area, you guys can kind of see there's no steam or heat from lava flow right in there. Oh, look, there's a little bit of glare right from that angle right there. Let me adjust the iPad a little bit. There we go. There we go. So, yeah. So Pohoiki still stands. We'll have to, as a community and government, figure out what to do about actual boat access right through there, right? That's not actually looking that promising right now without kind of some either the sand moving long-term somewhere else, or if it stays there in the long-term, some kind of long-term dredging project, which kind of be very high in maintenance, or whether you have to relocate that ramp somewhere nearby. I'm not sure how that's going to go, but in any case, it's fascinating. There's actually a little warm spring right over here, right? So this little piece of ocean is likely to be a new warm pond, the brackish water warm pond that's naturally formed there, even if just temporarily. So that's a fascinating addition we have. Here's a different view of it right there. You can see the sand bank that's piled up here, and it's basically blocking the entire ramp area right through there. And looking farther up, you guys can see maybe a little bit of steam, back in here, right in there, and there, but a lot less. You don't see some huge entry like we've seen in the past. Another closer up view right there. There's the Hale. And this is in the Kapoho area, right? You guys maybe saw this on our feed with Ikaika a few days ago, but there's a lighthouse. A big sand berm right here. And we have another little tide pool back here in the Kapoho region. This one may also be thermally heated. It's hard to see. This may be the one that's being referred to as possibly the new Champagne Pond. And if not, it's close by. I haven't been there. I can't tell you exactly how it is, but now that we're have a chance to look at these areas, just like we suggested a few weeks ago, we're actually seeing there's a lot of creation that came out of this as well, and amazing places we're going to get to go and explore and experience. We're not sure when. That's a whole other conversation, but at some point we will be able to go in and see those things and enjoy them. And that's really a testament to the changing force of the island, right? So how many people that actually came here to the island because of this power of creation, that comes with destruction as well. So there's that. So here is let me go back to this one. This is a picture of Fissure 8. It was taken, I believe, 2 days ago by USGS, and it's looking straight down. And you guys can see, kind of cracks of the pieces of the rim above. The highest pieces are sliding in. You can see they have a long way they can kind of go down and in. And we have a couple little ponds of lava there and there with a lot of crust. In the daytime, you don't usually see anything except the silver. So there it is, the silver, but it's probably still bubbling and red through there. Keka reported glow from the area this morning, so we know that it's actually still putting out glow. And here's a USGS image from yesterday, and somehow I found some glare. Here I am. There we go. So there you can kind of see a little bit of the red poking through the crust, but it doesn't seem like it's moving very much. It's mostly crusted over, and it seems like it's definitely getting deeper and deeper every day. So let's see what pictures I have from today coming in, but yeah, let me check that out here. So all right, let me turn this around. You guys get a look at the cave while I see what other photographs we have coming in. One thing I did not mention yet is that we have reports that the Mauna Loa fire is out today. Report first from Mick Calber this morning on his post-flight interview on Hot Seat Hawaii. They flew over the area and saw the scar of the fire and saw that it was all put out, in fact. So let me see here and find a picture for you guys from today by Scott Wilson. So these were from 10:15 this morning, and you guys can kind of see the extent of the sand all through there, and it's hard to see right in the middle there, but let's zoom in, give you guys the best possible zoom here, and you guys can see the sand actually goes all the way into here, all the way through. So that's what's going on in there, and I don't have, let's see, I don't know right now of any other photographs of the fissure. And that's basically what we got for photographs, I believe. Let me see if there's any other info here that I can share with you guys. I think I may have covered it. There might have been something else that I was hoping to share with you guys that's escaping my mind right now, but let me come back up and see if there's any other questions. And I see a lot of support for leaving the sand there, so that's great. So let's see what the community decides about that. Pohoiki is definitely a new place. And let's see. I think I maybe have caught up with you guys. So someone asked about lava going in the southeast rift zone. Yeah, it's okay. So I mean, that's what we're not really sure about, and that's what we're trying to examine the tilt patterns for. So what we can say overall is, maybe recap this. This is what I started off early on in my broadcast, so it is worth going through it again. So here's our tilt plot right now. And what we see overall on our 2-day plots at the summit is basically a big downward trend. There's a little oscillation, a little less steeply, a little more steep, a little less, a little more, but down overall. Pu'o'o, same story. A funny little bump signal here today. I'm not sure what's going on there, if it was some little collapse or some instrument adjustment, or if it was raining right there. But basically overall a downward trend as well with those oscillations. This one over here was most likely rain, right? So it could have been some increase as well naturally, but it's hard to kind of separate it from the rain itself. And now looking at the week-long plot of both together is more useful because we have a smaller range, a 5 microradian range right here from 3 to -2. And you can see that overall it is a kind of overall decrease. We had this big hump right here in a summit signal, right? But actually since then, I gotta come back out. I guess you guys can see the whole trend of it. It is still a downhill trend right there. This bigger hump we have speculated might actually be associated with this earthquake right in here, the one that was at 4.4 that seemed to have broken a slight little different pattern coming up, but overall the pattern is still of deflation. You know, even after that slight little adjustment, it's still deflating fairly regularly. So the fact that both the summit and the rift zone are deflating means that pressure is dropping in both, right? And I believe that you know, that's the fundamental big picture story, is that the lava pressure is decreasing in both. If we kind of microanalyze this and we say, okay, well, there is this oscillation in pressure, and the oscillation may just be from the way that the lava is draining or depressurizing in there, or, you know, that the system is feeling the change in pressure, that the height of the peaks for the summit correspond to like the lowest spots at Pu'o'o, and then the highest spots at Pu'o'o, lowest at the summit, lowest Pu'o'o, highest at the summit. You see there's this kind of a mirroring pattern there that we're seeing, right? This thing is kind of has an inflection, an upwards inflection, when this one's got a downwards one, this one's got an upwards inflection, this has got a downward one, right? You don't often see like both things going up together, except like a place like right in here. And this is where I believe was the rainstorm right in here. So the rain actually is heavy, and it weighs down the ground, and it actually causes the ground to move and settle and sink from the weight of the water, and that's why it actually changes the signal. So that's why the water makes a difference. So basically what I'm saying here is this, whoops, what did I touch? This connection, this kind of mirroring pattern of the shape of the graph shows that there's some connection still between the rift zone and the summit. And the connection may be a pressure one, right? You know, I'm trying to look at these, and it's hard to exactly say because the amounts of variation are so slight, right? But you know, it's hard to say if like the trough of this area right here, right, might be right in here, right? If I could pick an hour, I'd put it right in the middle between 6 and 12, right? So let's call it 9. And if I go down here, the peak, there's a peak at 9 also, right? But is it really at 9 or is it at 10? Is there a slight delay? I can't really tell on this scale if there's a delay from here to here, right? If there's actually lava, magma moving from this area into this area, I can't be sure about. But what I do see is there seems to be some pressure connection between the area up here and down here. And without more information, without having it without you know, going into it in more detail, and you know, when we're looking at the scale for looking at this little hump right here, right? So between, that's probably the height of 1, 2, let's call it 2 of these boxes, right? More or less. If we shift this up to here, then this goes up to there. That's 2 boxes basically, and that is 0.1 microradians. So a tiny amount. So it may not be very prudent to be analyzing like, well, where exactly is the peak of this thing, and am I sure that this wasn't the rain signal right here, and what else is going on? When it's this small of a signal, then it's kind of hard to really say conclusively linking it. Okay, well, you know, definitely lava is leaving the summit and going into the rift zone. If I see a spike at the summit, let's say a spike that goes up in a range of, let's say, 5 microradians, 10 microradians, increasing here, and then I see it follow in the rift zone, another 5 microradian pattern, then I'll say, okay, yes, now there is our conclusive signal that lava has entered the summit and has worked its way into the rift zone as well. So overall, I don't see that. What I basically see is depressurization on both ends of it, right? So both of them are basically depressurizing. And that is why, you know, now 1 week, a little more than 1 week after after the last summit collapse, this is why I'm saying that, you know, we have a lot of reason to be optimistic that it does look like the eruption is actually ending, at least this phase of it. You know, there are lots of eruptions in Hawaii that kind of happen multiple times in the year, right? We could have another eruption this year still, even if this one ends this year, right? So I'm not saying this is over forever by any means, right? I'm just saying that this particular dynamic of how this one went on, that's what I would kind of encapsulate as an eruption, and why I separate this from Pu'o'o myself as well. I would say that this is basically coming to an end based on that, you know. So like I said, USGS is going to be more prudent and wait at least a couple of weeks, because that's at least the longest pause we've had that long. And, you know, based on what we see now, I'll be surprised. It could happen, but I'll be surprised if we see a big inflation signal coming in. You know, we haven't seen anything yet. We just see constant deflation going on. And I think that's why I have the stance that I do, right? So that's the story today. And we'll keep our eye on a tilt, especially to see if there's any more signal of coming in, right? If we kind of see this long-term decline with these small oscillations matter less and less and less, as long as the big pattern is down, down, down. And that's the antenna cut out. Okay, I'm back in green now, so another hiccup, you guys. But answer a couple last questions before my battery runs out here. But Gabe asked about lava delta collapse. Lava delta collapse is actually still very much possible. It's going to be possible, you know, through the entire winter. And, you know, after we get through the big wave season, then maybe we can be more confident that it's basically settled out there, right? And, you know, a couple earthquakes like the ones we've been having don't hurt either, because you want to kind of settle that whole ground as much as possible. Give anything that's unstable a chance to slide or crack before people are walking around along on it there. So as far as the summit deflating is deflating at a much slower scale than before, right? And so I don't think it's going to lead to another collapse at this point, you know, and we don't see the same mechanism before, you know. Not to say, you know, that couldn't happen. We could be, you know, there could be another chapter in this eruption coming ahead of us that we don't anticipate at this point. But the bottom line is we don't anticipate it. We don't see any sign of anything else coming at this point in time. So the lava levels are dropping within Fissure 8. They're still in there. Lava is still visible. So, you know, based on that, you know, you might say, okay, it's not really over till lava is totally out of sight. You know, lava is still draining out at the ocean entry. It's might be doing that for another week. All right, we're back to green. So I'm not sure what's going on with my connection, but I'm going to kind of wrap it up here and sign off for you guys. So thank you guys for all the questions and all the feedback. And I will keep an eye on a tilt as usual, you guys. And, you know, we might kind of keep this slower pace of updates as much as we can, just because we're all I suppose a little weary from the marathon that we've been through, from a 3-month huge effusion of lava coming out there. So we'll keep an eye on things and keep you guys updated. I know everyone wants to know what's going on, and so, you know, kind of we'll keep up doing daily updates for sure. A little less on the weekend maybe after a celebration day, you know. So I didn't do one yesterday, but we'll keep doing it basically every day, maybe once a day, as long as we need, until there's, you know, real signs that nothing else is changing that's worth talking about, right? So, and at that point we can talk about whether you guys want to hear more geology talk of, you know, some different places. There's lots of other things to teach you guys about. For whoever's interested, to kind of keep watching, kind of long term, we'll keep doing this as well. So, so yeah, thanks you guys. Thanks everyone who's contributed. Thanks for all the questions and the feedback. And yeah, we'll talk to you guys again soon. And just to recap, you guys should look for the with the hub Puhonua